Hello, everyone, and welcome to section 5.2 in Precalculus. This is verifying trigonometric identities. So the first example you can see I've written 3 times. I'm not always going to do that, but I wanted to show you that there's tremendous variety in how you do these problems. So I will do the first one 3 different ways. And then going forward, I'll just show you one possibility, but certainly you might be doing these problems in a different way. My first step is to always draw a line down the middle. The purpose of that is to make sure I don't forget you cannot add to both sides, subtract from both sides, multiply, divide, square. You can't do anything to both sides. You can work independently on both sides, but you can't do something like as if you were solving. So strategy number 1 is to break this fraction into 2 separate fractions. I have a single denominator, a monomial, and even though you're used to getting a common denominator to put 2 fractions together, instead I'm actually going to use that to take the 2 fractions apart. And then secant squared divided by secant squared is 1. And 1 over secant squared, using my reciprocal identity, is going to be cosine squared. So hopefully you remember that sine squared plus cosine squared is equal to 1. Sometimes people like to put those identities into the problem. You can't do that. You can replace the 1 with sine squared plus cosine squared and put it in that way, but I don't want an equal to in the middle of this problem. And now my cosines cancel, and I get sine squared, which was my answer. So if you have the 2 sides match, then you can be done. Sine squared. Sometimes you can bring that down just to show you that you're finished. There's really nothing to box. Sometimes people box this. Sometimes people just put a smiley face there, something to let me know that you've proven it. So notice there's no equal to signs, and anybody should be able to follow these steps. You're not just solving and getting an answer, you're showing the steps. The grading will be in the steps, so make sure you show each one clearly. Okay, method number 2 for doing this would be to bring this secant to the top, just like over here we said 1 over secant is cosine. If I'm dividing this entire expression by secant, I could say, well, then I'm multiplying this entire expression by cosine. This is another possibility. And again, you can put that line there if you want to. And then I could multiply out cosine squared times secant squared. Notice that I'm not always saying the theta, but you do have to write it every time. And then secant is 1 over cosine, and since it's squared, it's 1 over cosine squared. And then my cosines cancel, and I get 1 minus cosine squared theta. Now, last time I actually wrote this out. I changed the 1 to a sine squared plus a cosine squared, but it's possible that on your list of identities, this is just one way to write this. Being able to say sine squared is 1 minus cosine squared theta. That is an identity. So I could literally just go from here to here. And then, like I said, I would put the other side on there also, and then indicate that you've finished. I probably wouldn't do it this way, but this is just giving you another option. Option number 3. Sometimes people look at secant squared theta and 1 right away, and they think, oh, I know there's a rule about that. And there is. 1 plus tangent squared theta is equal to secant squared theta, which means you may also have this written on your appendix, that tangent squared is equal to secant squared theta minus 1. So somebody might think, oh, I'll just replace that with tangent squared theta. This is a great strategy. And I'm actually not going to put that equal to, so I'm going to put my line. So where people have trouble here is they want to now change tangent to sine over cosine, but that'll give them a complex fraction. So you might want to move the secant first to the top and call it cosine squared theta times tangent squared theta. And now when you change tangent squared to sine squared over cosine squared, you're not trying to deal with a complex fraction, which is always nice. And then I just get sine squared theta, and I'm done. So it's up to you which way you do it. I'm sure there's even actually another way to do it, but I've tried to show you some variety to make sure you understand that every single person is going to do these slightly differently, and that needs to be okay. Just another note about this complex fraction. If you had changed tangent squared to sine squared over cosine squared, and then you changed your secant to 1 over cosine squared, this still wouldn't have been a disaster. You could have either flipped and multiplied. That's a good way to do it. Or you could multiply the top and the bottom. Even though you're not allowed to multiply both sides by something, you are still allowed to multiply the top and the bottom, because that's just multiplying by 1. And then this cancels, and this cancels, and you get sine squared over 1, and it would have brought you right down to that step. So many options. So there are 6 more problems. You might want to try some of them on your own, but obviously I'm going to do them for you. So another strategy that's really good is to get a common denominator. The biggest problem I have with students is they only show me half of what they're doing. So they know they want to multiply by, I guess it's alpha, 1 minus sine alpha, but you're actually multiplying it on the top and the bottom. And because all the grading will be in the actual steps, make sure you show that. So I'm multiplying this fraction by 1 plus sine of alpha on the top and the bottom, and I'm multiplying this fraction by 1 minus sine of alpha on the top and the bottom. This numerator becomes 1 plus sine of alpha. This numerator becomes 1 minus sine of alpha, and because they now have the same denominator, I can just write it as a single denominator. 1 plus sine of alpha, 1 minus sine of alpha. Now, sometimes it's going to work to multiply that out, and sometimes it's not. You're always going to have to be thinking a couple steps ahead. So in this numerator, the signs end up canceling, and I just get 2. And I am going to multiply that out. So a little bit of forethought here. I have sines, but I need secant. Secant is related to cosine. Well, the only way you're ever going to change a sine to a cosine is if it's a sine squared. So I am going to multiply it out. First times the first, outers and inners cancel, and minus sine squared alpha. Again, that is an identity. It is cosine squared alpha. I'm not going to keep writing off to the side why that's true. It was back here on this first page. And then a cosine squared on the bottom is the same as a secant squared on the top. And we're done. As you can see, these are getting harder all the time. So we're going to be practicing them for days. Number 3. Lots of different ways to do this one. You could FOIL it out. You could change its form. I'm gonna try looking for this tangent squared x plus 1, and sure enough, that is an identity. Whenever you see a squared and a 1, you gotta at least consider that possibility. So I'm gonna change this to a secant squared. And then my cosine squared x minus 1. Now this one is a little bit trickier. The actual identity is sine squared x plus cosine squared x is equal to 1. So what would cosine squared x minus 1 be? Well, if you want to get that form, you can either have all the different forms written on your appendix, or you can replace the 1 with sine squared plus cosine squared. Or you can work off to the side and say to yourself, well, if I subtract sine from both sides and I subtract the 1 from this side, I can put them on reverse sides. So negative 1 plus cosine squared is negative sine squared x. but you are allowed to have every version of those identities written on your appendix. Now I need to get it to be tangent, so I think to myself, secant is 1 over cosine squared x, and then sine is going to stay there, but now I can do numerator times numerator and denominator times denominator, and I get negative tangent squared x. So the trickiest part about this one is definitely this little maneuver right here. I can't stress enough that please do not try and fudge these. I've been grading these for like 30 years. I don't want to see you just make something up to make it work. I'm going to be checking every step, so it's important that you show that. So alternatively, if you didn't have this form written on your appendix, another way you could have done it is you probably have the form cosine squared is 1 minus sine squared. This would be an unusual one to have on your appendix, but you probably have that cosine squared is 1 minus sine squared. And then you can see that the ones cancel and you get negative sine squared x. So make sure you get that. Number 4. So a lot of times when I see something that I just don't even know where to begin, my first step is to change everything to sines and cosines. So tangent is sine of x over cosine of x, and cotangent is cosine of x over sine of x. And you can even change the other side. You're allowed to work on both sides independent of each other. So I'm going to change that to 1 over cosine of x, and the cosecant would be 1 over sine of x. I tried to write it as 1, but I'll do that in one more step. So 1 over numerator times numerator, denominator times denominator. So now I could make the left side look like this instead of secant x, cosecant x, and that might be easier for me to do. Whenever you have two things that somehow become one thing, it's always going to be because somebody got a common denominator. So again, make sure you show your work appropriately, that you are multiplying this one on the top and the bottom by cosine of x. And on this one, to get a common denominator, this one needs a sine of x, but you must show it to me on the top and the bottom. So now I have sine squared x plus cosine squared x, and they do have the same denominator, so I can write it as a single fraction, sine of x times cosine of x. And now is when it helps to maybe look the other side. What am I trying to get? Well, I'm trying to get a 1. How is that oh, see, it is a 1. So not everybody recognizes this at a first glance because you haven't been doing math for 30 years yet. But sometimes just looking at the other side might trigger something. And sure enough, literally, that is the next step. Sine squared plus cosine squared is 1. You do not need to go back to this form, secant of x, cosecant of x. As soon as the two sides match, you are considered done. So if you want to work a little bit on this side and a little bit on that side, totally fine. Just don't do things to both sides, like add 1 to both sides, square both sides, things like that. Number 5. So I'm giving you a second here because I want to see if you see it. Do you see it? There it is again. Sine squared theta plus cosine squared theta is 1. We are much closer to our answer already. And then there's 2 ways to tackle it from here. I'd be inclined to change everything to sines and cosines. I think that's a great strategy. So I'm going to take my secant and I'm going to move it to the top. A secant on the bottom is a cosine on the top. And I'm going to leave this cosine here. And then cosine squared over cosine squared is 1. That was a nice one. Number 6. So I'm going to remind you of a strategy that we learned in 5.1, which is multiplying by a conjugate. So you're never going to change a sine to a cosine. You will always need to have it be a sine squared. And the way you do that is to multiply by the conjugate. Make sure you show that you are multiplying the top and the bottom by 1 plus sine of y. This is a good example of where I probably don't want to distribute. You're going to have to make that decision. When is it worth distributing the cosine and when is it not? So on the bottom, first times the first is 1. The inners and the outers cancel. That's the whole point of a conjugate. And 1 minus sine squared y. Now, some people at this point actually make a mistake and they're like, oh, if I factor that, I can cancel. It's such a great thought, but that works because you just put that there. So don't undo it. You put it there for a reason. And that reason was, again, you should have this on your appendix, that cosine squared theta is 1 minus sine squared theta, Pythagorean identity. If the only way you have written on your appendix is this one, that's totally fine. It just means that then you'll do a little extra step of replacing the 1 with sine squared plus cosine squared. But if you also understand it to mean this, then you can right away just change that cosine squared theta. But in this problem, cosine squared y. And we have a cosine of y on the top. 1 plus sine of y. And now I think you can see why I didn't factor it or didn't multiply it out. So one of these cosines cancels with one of these. And I'm left with 1 plus sine of y over cosine of y. So pretty much you might be thinking, yeah, Mr. Shaffer, all you did was flip that upside down. I realize that. I got a plan. Wait for it. So I'm going to change this side to all sines and cosines, which would mean that this one would become 1 over cosine of y. And my tangent is sine of y over cosine of y. Normally, you'd have to get a common denominator, but they actually already have a common denominator. 1 plus sine of y all over cosine of y. Does that look familiar? We did it. Okay, so I'm going to just bring this down to show that the two sides are the same. If you had wanted to continue to work on the left, you could have. You could have kept going or keep going on the right. You didn't have to work on the left side at all. If I'd kept going on the right, I could have separated these into two separate fractions. And then this would have been secant of y, and this would have been tangent of y, and I wouldn't have had to work on the left side at all. There's just so many choices. So hopefully you're finding a way that works for you. Okay, last one on this first section. So I see a couple places where I could multiply by a conjugate, but I also see that this one, the difference is that on this one I had a cosine and a 1 minus sine, and I knew if I multiplied by the conjugate, I'd have a sine squared that I could change to a cosine, which would cancel that cosine. In this case, multiplying by the conjugate isn't as good as maybe just separating it, because now I have sine over sine, which ends up just being cosecant of theta minus 1, which starts to put it in the terms that this one is over here. But I have a cotangent squared and a cosecant. So we're going to use a rule that we haven't used yet today, which is the third Pythagorean identity. 1 plus cotangent squared theta is equal to cosecant squared theta, which means that another way to write it would be cotangent squared theta is equal to cosecant squared theta minus 1. And the reason that I'm going to use that is because then at least this side will be all in cosecants. And since I was able to make the right side all cosecants, that's always a good first step, is to have everything be in the same trig function. And I don't know if you see it, but you can factor this. Factoring is everywhere, isn't it? I know. It's in algebra, it's in trig, you can't escape it. All over 1 plus cosecant theta. You do not need to show me that that reverses. That's the commutative property. So cosecant theta plus 1 is the same as 1 plus cosecant theta. So I can cancel those. And now I just have cosecant theta minus 1 is equal to cosecant theta minus 1. And I'm done. So on the next page, I just tried to sum up some different strategies that you could use. Changing everything to sines and cosines, getting a common denominator, or conversely, breaking a single fraction into two fractions, uncommon denominatoring it. We multiplied by the conjugate, we factored, we worked on both sides independently. Most importantly, you just need to know your identities. You have to have a great appendix nearby or have them memorized. Little warning, do not add to both sides, subtract from both sides, square both sides. Don't do anything to both sides. When you are trying to use an identity, just use it. I don't want any equal to signs in the middle of the problem. And finally, like I said before, do not fudge it. I'm actually grading the work, not just the answer. You have the answer. It's a verification. So I'm giving you the answer in advance and you're showing me that it is the answer. So obviously I need you to actually do them out. So on this worksheet, these next 5 problems are what you should try to do on your own now. They are very similar to the previous problems. So if you have to, just go back and look at one of those. But if those made sense, then these should be a piece of cake. There are more to try in your book on page 387. Have a great day.